Now we are seeing that there is infrared and Raman activity of molecular vibrations. So when the molecules are exposed to infrared radiations having frequencies that are equal to the fundamental vibrational frequencies of the molecules, and the vibrational transition takes place by Tybor mechanism. So the probability of such transition occurring and also depends on the relationship between the molecules, electric dipole moment and wave functions of the ground state and higher vibrational state. So for IR active, for a molecular vibration is seen in infrared spectrum, it must change. This is the main conditions for the IR activity. So it must change the dipole moment of the molecules. The dipole moment vector have the same symmetric properties as the Cartesian coordinates x, y, and z axis. For Raman activity, so main conditions for the Raman activity is the vibration should involve a change in polarizability or induced dipole moment during oscillation. So, to determine such Raman active vibration, the symmetry of the ground state, the symmetry of the excited state, and the symmetry of the polarizability operator should be known first, and the overall direct product has to be determined. So, for Raman activity, so Raman spectroscopy measures the wavelength of light scattered by the molecules. So, the certain molecular vibration will pass the frequency of the scattered radiation. It should be less than the frequency of the incident radiations. So, for molecular vibrations to be seen in Raman spectrum, so this is the main condition. So, it must have the polarizability of the molecules. So the polarizability has symmetric properties as the quadratic functions. So for IR spectroscopy, it has the Cartesian coordinate functions of x, y, and z. But here for Raman activity, it should depends on the polarizability of that is function of that is quadratic functions of x, y, y, z, x, z, x square, y square, and z square. So we are very well known, and we are previously studied that how do we find out the molecular vibration for water molecules. So totally the finally we have got that is three normal modes of vibration for water molecules. So the vibrational modes of water molecule has 2A1 and 1B1. That is two types of symmetric, that is symmetric mode and one antisymmetric mode. In the two symmetric modes, one is have that is symmetric stretching, another one is bending vibration. This is the antisymmetric stretching vibration. This is the complete character table for CTV point group. We are already known as we have to check the activity of IR by using the Cartesian coordinate functions of x, y, z. And for Raman activity, we have to find out the quadratic functions of x square, y square, z square, x, y, z, and x, z. So by using these value, that is these two column, we have to find out that Raman activity and IR activity for water molecules. So by using the molecular vibration of water molecules, that is 2A1 and B1, first we have to select the A1 mode. The two vibrations with A1 symmetry have Z as a basis functions. So see that the A1 symmetry has the Z as the basis function. So we will see that the infrared spectrum of water in Z axis. So this result two peaks at different frequencies in IR spectrum of water. Okay. Next, the two vibration of A1 symmetry also have quadratic basis function. See that? That is A1 symmetry also has the quadratic function. So they will be seen in Raman spectrum of water as well. So both of them having the IR and Raman activity. So IR activity is focused in Cartesian coordinate of Z axis, and the Raman activity is mainly considered in x square, y square, and z square axis of that is quadratic functions of x. Next, the two vibrations with A1 symmetry will appear as two peak in both IR and Raman spectra. the two frequencies observed in IR and Raman for these vibration will be same in both the spectra. So the vibration with B1 symmetry, okay. So next we will move on to B1 symmetry. The vibration with B1 symmetry has X, okay, X and X is set as the basis function, okay. So this vibration will be both IR and Raman active. IR and Raman active. So this vibration will appear as a peak with different spectra frequencies. So totally from the above discussion, we conclude that the water molecules are active in IR and Raman regions. So both IR and Raman spectra should show three different peaks.